Yes, in this video we're going to learn a new property. If you remember, the property is logarithm base AB plus logarithm base AC is equal to logarithm base AB times C. If there is a multiplication between if there is addition between the logarithmic expressions with same basis, main parts we have to multiply. If we apply the property on the question, logarithm base 4 2 plus logarithm base 4 8, it should be equal to logarithm base 4 2 times 8, which is equal to logarithm base 4 times 4 16. For 16 is the base is 4, that's why it's going to be equal to 4 to the power of 2. It is 2 to the power of 4, but base is not 2. That's why we should write in terms of 4. And it's going to be equal to logarithm base 4 square. It's going to be equal to 2 times logarithm base 4. That's equal to 2. Okay. The next one, logarithm base 2 3, logarithm base 2 5, logarithm base 2 1 over 15. All there, here the operation between them, addition. So we are going to multiply all of them. Logarithm base 2 3 plus logarithm base 2 5 plus logarithm base 2 15 1 over 15, actually 1 over 15 is going to be equal to logarithm base 3 times 5 times 1 over 15 it's going to be, and that's equal to logarithm base 3 times 5 times 1 is equal to 15 over 15. That's equal to logarithm base 3 1. If you remember, logarithm base 3a1 is equal to 0, so this is going to be equal to directly 0. Why? Again, I'm repeating, logarithm base a1 is equal to 0. That's the reason for this one. Okay, here we are going to multiply. The bases are same, so we are going to multiply only 6 and 6. So 7 times 3, it's going to be equal to 21. Yes, base 6 21. 9 and 9, so we are going, there's an addition, plus sign here. 7 times 2 it's going to be, and it's equal to 14. Here 3 times 5, the base is 3. 3 times 5 is 15, so logarithm base 3 15 it's going to be. Yes, here it is. Here 8 and 8, the bases are same. 8 times 6 is going to be 48, and logarithm base 8 48 it's going to be, and the last one here it's going to be logarithm base 9 42. Okay, here this is the next property. If we have the difference between the logarithmic expressions, we should divide them. So logarithm 9 11 minus logarithm 9 11, normally it's equal to logarithm 9 1. Okay, 11 over 11. Normally the terms here, as you see, 9 11 and 9 11, they're same. So when you subtract two same terms, the result it must be 0. Also 9 1 is equal to 0. We know that one. 6 11 and 6 11, 6 1 again. 6 15 minus logarithm base 6 10 is equal to 15 over 10. 15 over 10, we know it's equal to 15 over 10 is going to be equal to 3 over 2, so logarithm base 6, 3 over 2. Here it is 7 over 12, it's going to be the last one. Exactly, this must be 15 over 12. They have common 3 divisor, so when you divide by 15, 3, it's going to be 5. And when you divide 12 by 3, the result is going to be 4. So logarithm base 9, 5 over 4 is going to be. Okay. So if we have addition, we are going to multiply the terms. If we have subtraction, we are going to divide them. Logarithm base 3, 15. Logarithm base, also the important part here, the bases must be same. All the bases, as you see here, they are 3. So logarithm base 3, 15 times 6 over, the minuses are going to be denominator, over 5 times 2. It's going to be equal to logarithm base 3, 5 and 15, if you simplify, it's going to be 3 and 1. 6 and 2, if you simplify, it's going to be 3 and 1 again. So 3 times 3, logarithm base 3, 9. It's equal to logarithm base 3, 3 square. It's going to be equal to 2 times logarithm base 3 and 3. This is equal to 1. Then the answer is 2. Okay. What about this one? Write each single logarithm. The bases are same, but we have here the powers. We don't have the in front of them we have coefficients. So we should write these coefficients as a power firstly here. Then we should solve the question. For the first one, what I mean now, 2 times logarithm base 3a plus 3 times logarithm base 3b minus logarithm base 3c, it says. Here all the bases are same, but we have extra coefficients here. This 2 and this 3. What are we going to do? The formula for the addition or division, logarithm base ab plus logarithm base ac is equal to logarithm base ab times c. What is the extra here? The coefficients, because here we don't have any coefficient, here we don't have any coefficient. What we are going to do about these coefficients, we are going to send them back again to the power, as a power to main part. If you remember, logarithm base a b to the power of n is equal to n times logarithm base a b. What happens? This power comes in front. Now we send it back. Okay, let's continue with this one. Then it's going to be equal to logarithm base 3a square plus logarithm base 3b cube plus, minus logarithm base 3c. Now all the expressions has base 3 and they don't have any coefficient in front of them. We can write these expressions as logarithmic in one logarithm. Here it will be equal to logarithm base 3 a square times b square over c. A square and b square, the signs are plus, so they are going to return to numerator. For the c, the sign is minus, it should return to denominator. For the second one, b, logarithm 2 a to the power of, if I get this one back again, to the power of 1 over 2 plus logarithm base 2b to the power of 3 minus logarithm base 2 to the c to the power of 3 over 2, it should be. And if we write the 1 over 2 as radical expression, also it is possible. Logarithm base 2 square root of a plus logarithm base 2b cube and minus logarithm base 2. This is going to be the 2 here square root, and the 3 is the power of c. Okay, then here these two, they have a plus sign, that's why they are going to return to numerator. Logarithm base 2 here, root a and b cube written to numerator, and the sign is minus, it should be divided, so it should be written here over c cube. It should be. To know this one, logarithm base 10a written as logarithm a. So logarithm base 10(5) is written like logarithm base 10(5), but the base is not written here, like invisible, like a to the power of 1. How is not written? And we are writing instead of a to the power of 1 a, or instead of square root of a, we are writing root of a like this. For the base 10, we are not writing in the logarithm, and when there is no base, we know that it's equal to 10. So when it says logarithm base 30, we know the base exactly 10, so it's equal to logarithm base 1030. And I'm going to try to write this one in terms of 3, because 3 is p. Logarithm base 10, 3 is equal to p, because here logarithm base 10, 3 is equal to p. So it's going to be equal to logarithm base 10, 3 times 10 is equal to logarithm base 10, 3 plus logarithm base 10, 10. Here logarithm base and the main part it's same, that's why this is equal to 1, and logarithm base 10, 3 it's equal to p, so logarithm 30 is equal to logarithm 10, 3 plus 1. If we say logarithm 30 is equal to, instead of 10, 3, I'm going to use p plus 1, it's going to be. What about 10 over 3? 10 over 3, we are going to write logarithm here. This is the first one and this is the second one. It's going to be logarithm 10 over 3 means the base is 10 here. It is not written, so it should be 10. Logarithm base 10, 10 minus logarithm base 10, 3. This expression, we know it's equal to 1, so it's going to be equal to 1 minus, this expression is equal to p, so one of them is p plus 1, the other one is 1 minus p, it's going to be. Okay. Yes, sum and difference formulas of A questions, it seems difficult, but normally as a sum and difference when you write, like in the previous questions, like these questions, how we collect them together, a squared times b squared over c, when there is a plus sign. If we are adding them, then we are multiplying here inside, and if we are subtracting, we are dividing. In this question, if we are multiplying, we are going to add. If we are dividing, we are going to subtract. So logarithm base a b cube c squared over d4 e5 is going to be equal to logarithm base a b cube plus logarithm base a c squared minus logarithm base a d4 minus logarithm base a e5. Here, what is written on the numerator with plus sign, what is written on the denominator, it's going to be with minus sign. Logarithm base a b, this power comes in front, that was 3, and it's going to be equal to 3 times logarithm base a b plus 2 times logarithm base AC minus 4 times logarithm base AD and minus 5 times, this is going to be e to the power of 5, 5 times logarithm base A going to be. Okay, this is the open form of sum and difference of logarithm base A. The question is asking this one. What about the V1? For logarithm base A, here this is 5th root of b plus c square over d minus e cube. You have to be careful in this question because this cube belongs to d minus e. That's why you have to leave like this, and it's going to be logarithm base a b plus c to the power of 2 over 5 and d minus e to the power of 3. Here we cannot separate this plus sign and minus sign. If there is multiplication between them, yes, but if there is addition and subtraction, we cannot separate. That's why it's going to be equal to logarithm base a b plus c to the power of 2 over 5 minus logarithm base a d minus e to the power of 3. If you want to write these powers in front of the logarithm, 2 over 5 logarithm base b plus base a b plus c and 3 times logarithm base a d minus e. Students generally asking this question, can we separate them? No, because the operation between them addition. The rule says multiplication. For if you want to separate, this operation should be multiplication. So you cannot do any operation here. This is the important part.